Okay, let's show you a quick preview of what we're doing with the Boston Transit demo. I've added a couple of new features here, which I think are pretty cool in the way we involve search, geocoding, some LLM, and some display stuff, and a couple other things we learned from working on the Irish Rail and some other projects. So first thing I'm going to do is here at the conference coming up soon. As you saw, we already got results back, but I can't navigate as fast as this code will run. So I asked a question: what buses are near the Hyatt Regency in Boston? I don't know. I did Boston twice. I'll have to edit that. But that's where the hotel is for the conference coming up May 7th, 8th, 2024. So I sent that into Slack, and I have within NiFi a reader. And that reader I use for all my apps. It's just a dedicated Slack processor in NiFi. And after I get it, I push those results into a Kafka channel. So one consumer is getting it, and then we distribute it to everyone who may need it, including our friends who are using this app in Boston. And live during the conference, I'll give people access to the Slack. So you can use that to ask questions, and we'll see how things work when it's not the happy path. So we get that message in, and we can look at our data provenance. This is the one that just came in, and we could see what's in there. It came out of Kafka. We could take a look at the actual data, and there's a lot of stuff in here, but what buses are in there? That question is part of that big JSON. And I'm going to parse out the fields I need. And then from there, I'm going to take the message that I wrote, and I'm going to try to extract all the NLP entities out of there. So I'm doing some simple NLP processing in here to get out, is there anything useful out of there? And then I have another processor, we'll go into this in the talk, that tries to parse out addresses. And then I'm going to try to set a location based on those ones we got back from the NLP parsing. And next step, once we started that basic processing, I'm going to, based on types of queries, I am going to look, is this a bus one, which we're doing, or do you want to know a stock price or the weather? Those are just some that I handle. And you'll also see I'm also have another consumer of this Slack message that's calling Mixtral and getting LLM result there, maybe using RAG, maybe not, depending on if it's something I know I've kept a document about. I'm loading my vector store with my articles from Medium and the PDFs of my talks. So that's not going to be helpful for where the buses are. Now you see if it was stocks, we go to the stock processing. If it's weather, we'll go to weather. But first, and very important, where am I? And as you can see, turned out to be really complex to know where you are. Now, Slack doesn't give it to me. Probably would be good if we set up a profile and you could just tell me this is my lat long and we'd be good with it. But that's probably not going to happen in this app. So first thing I do is call the census to see if they'll give me the proper geocoding for where you are in the world. I mean, maybe they will, maybe they won't. I'll take a look. What do we get back from that? We get back some data. Yep. So that one didn't find it. I'll pull out the lat long in case we get it. If we didn't get it, I'm going to try something else. I'm going to call Geocode Maps. They do a pretty good job. If they find it, great. We found it. Parse it out. We'll use that. Ready to go. Again, that one fails too. So I wrote another processor that calls another one, and we try that one. If that works, maybe we've gotten, what we're looking for. Were we able to get where we are? And it looks like we were able to find where you actually are, what's your location, and then get a lat long. Because we need lat longs to be able to query things that are in the real world in maps, in weather, all kinds of stuff like lat longs. So we have it. So what I'm going to do is use that lat long to query a Postgres table, which is pretty cool. So did we get results from that? It looks like we did. We passed them here. I only want 2 of them because otherwise I'm giving you a lot of results back. We'll play around with that. We could easily adjust it. Parse those out, and then I send them to Slack. So let's see if we gave you some results here. Now we'll look and we see my running of that query against my database is faster than my Mixtral results. And that told me where it is. We got that address, including county. And we got our lat long, which is important. And it told me what buses are nearby. Plus all that extra metadata. Just keep us honest there in debug. And there's the results from our Mixtral. And it actually gave us some information as well, which is pretty impressive. You know, maps don't change too often. So maybe this is one we could do all the processing there, but I like to include the newest stuff. So I have this function here within Postgres. I've found the calculation online. You'd install a package here. You can see all these other functions in there. This just takes that lat long of where you are and compares it to all the lat longs in this table. And if we look at this table, this is one of those flat tables that I loaded. Thank you, GTFS static load there. And that has all the lat long of all the stops. So we just use this function to get the ones that are close to it. Pretty cool. We'll just get back the ones we need. So when we look in our running, we take a look at the results we got back, and we got 2 rows here because that's what I asked for. And we look at them and we can see this is the distance. That's the name of the stop, lat long. Basic stuff we had on that table. And then we just return that to the Slack. I also push that to a Kafka channel in case you want to use it later, maybe in some Flink out of Linux or somebody else. But nice thing to do. So we can navigate you based on your message right to that. And we also do a lot more, but that's helpful. This is how we can get and share information on what's going on in a map, and I'll show you that in a minute. Some people want to just look at a map, see what's going wrong. Now, we could also push these alert to that same Slack. I'm still thinking of more features. But so what we have here is alerts. This is from the GTFS, which is the Google Transit format. So we're going to run this. I have a processor that gets the current alerts from this URL, which is updated pretty frequently. We parse it, enrich it. This is where I do a couple things where I do lookups against different tables. This one is the route table, because all they give you is a route ID. I want the long name, so I look that up. I want the stops, and I look up those stops. And what I'm doing here is merging them together and putting them in a cache. That cache is served up by this website hosted within NiFi, and that's this endpoint here. And this is a bunch of JSON with all those values. Why I want this, I could read this with a Jupyter notebook or with apps or with anything, but I've written a very small web page, open source in that GitHub, that takes all that, makes it into a table here. You can navigate through the hundreds of pages of information that are in there, but this gives you a nice way to sort it using data tables. And, you get all the alerts, but, we are like in this area for the conference, so I could see what alerts are nearby. There's going to be some service buses replaced during certain times of day during maintenance. Good to know. You keep an eye out. You think the bus is coming and it's not. Some other things, where you're going. I'm going to be going over here on the train, so it's good to know. But, we could zoom out. I'm getting them for the whole transit, which is all over. And these are just the alerts going on in the area. We have them here. Just a nice way to show you how we get to distribute this data, even though it's coming in pretty fast. But that's the the alerts. We also get trip updates. We also get vehicle positions. These are fun. I'm going to figure out how to combine that with our questions to say, hey, bus is coming, or bus is this far away, and maybe real-time tracking. Maybe do something like the Domino's thing where your bus is coming, going to get close. See if we're interested again. I'm not in Boston, so I don't know if that's too interesting to me, but maybe the New York one or the New Jersey one, or maybe just make one that's universal. It is a little harder, but we'll see what we could do. Now, the other thing we're doing, remember I said those static tables, they are all in a big zip file. A big zip file of comma-separated values, which I split out, convert to JSON, figure out the primary key, and then from there, do a little more processing to do all those different tables. They give you a lot of static tables. And then I build my SQL there, give it a unique table name, and then insert it into my database, which could be anything with a JDBC database. That's standard SQL, which is a lot of different databases. So we run that. So we have that data available for doing our lookups, on routes, on stops, and on when we're doing our, live Slack search there, which is kind of cool. If you have any more ideas what you might want to do with this information or things I'm not thinking of, like, hey, what about this? What about that? Lots of options there. But thank you for joining me for this quick discussion on this. And we'll have a lot more at the conference.